Kelly and I had a conversation about weather vanes in general, historically, and a couple of basic concepts about the mechanics of how they work. And then I'm going to demonstrate a couple of specific techniques that you're not necessarily constrained to have to follow. This is just one of the techniques. In fact, since Kelly knows more about it than I do, it's probably likely the techniques we talked about widely used. So, weather vanes basically have two main components that you need to consider. One of them is how it catches the wind, and the other is the rotation mechanics. I mean, there's really simple ones like ancient Egypt and stuff. They had just cloth hanging on the wall. This is weather vanes that specifically point into the direction of where the wind is going, so where the wind is going, based on what kind of vane you have. So basically, I may have some of this written down. We don't have an easel to post these up, so unfortunately. So what?
Somebody like Nick said he can hold them.
If Nick would like to hold it. So what we're going to talk about are these two basic principles. How it catches the wind and how it rotates. Thank you, Vanna. So basically you have these basic arrow styles. It's literally, it looks like an arrow. There's an arrow shaft, and they call the one end a fletching, and one end is the arrowhead. And that points because the mechanism that catches the wind is a drag, basically, right? So whatever it increases the amount of drag is the side that's always going to go in the direction that the wind is blowing. So if you have the arrow style, the fletching is going to be bigger than the arrowhead, and it's going to be pointing to the direction the wind is going. How they describe wind direction when weather, forecasters, the meteorologists talk about wind direction. It's always the direction it's coming. It's bilateral. So you have things on both sides of the focus of rotation, but the side that catches the wind the most, that has the highest drag coefficient, is the one that has the fletching. Then you have a banner style, and I'll actually run some pictures of and alignment is a little off. So ignore the lines on it, but here's a couple of examples. So basically, you have these arrow style. You have basic arrow style weird weather vanes. You have these flag or banner style weather vanes. Banner or flag style doesn't have a bilateral action. It has the rotation and then all of the material at one end. That is always going to point in the direction that it's going. So if that's the kind of weather vane you're using, you're just going to have to know that this radar is pointing south east, so you have the northwest wind. So whoever uses that kind of banner, you just and then you have the more ornamental.
So is the banner metal?
Okay, it can be. And in fact, it can be any material. It could be any material. But if you're going to make that metal, make it out of a metal that is resistant to the rain. So copper or bronze or brass, aluminum even if you want to. You can make it out of steel, and then you can make it. There are like this one right here is a banner style. It's got a date of 1598 on it, and that's it. Whenever the church or government building flew that weather vane, erected the structure. So that's the banner style. Yeah, and those are made out of steel. And the whole reason those work is because the rotation principle that we're going to talk about next, which they came up with hundreds or thousands of years ago. It works for everything. But it's not a fabric. Well, you know what, it should be a fabric. Like if Kelly has this one right here, and you could either put some sort of something to create drag, up here or in between, or you can just straight some canvas in there, and it's going to function the same way. All it's doing is it's catching the drag and then pulling to whatever has the highest drag coefficient in the direction. So, and then there's some ornamental ones. The ornamental ones are also bilateral. Material and size and rotation point. It's just you have to make sure that you have a bilateral wind direction catch, you have to have about the same amount of weight on both sides. And what determines what direction is put into is how much drag. So you use thinner, or you use more expansive or larger components on one side than the other. And as long as the weight is balanced, it will spin easily, and it will have drag will always catch the head. There's even one here of a carrot. So they have that set up so that it's balanced. Weight on the spindle, but there's more drag and feel in it. So those are the two principles that make a weather vane work. And for the purposes of the competition, you don't have to do your weather vane this way. You can do it any way you want, as long as it adheres to the minimum criteria. But for the purposes of this demo, I'm going to take the rotation next. I'm going to take the rotation mechanism. There's two. One of them is basically like a stop cut, like this one right here. And it's here kind of the friction gradient not being so high. Or there's the spindle tube method, which is what we're going to do. And Kelly even with a spindle here, spindle tube, and I have the same one as mine as well. Basically, it's a closed-in tube. It has two marbles. Glass marbles are recommended in the barrel cut. And why two? Huh? Why did he say that you use instead of one? I use two because the point of contact from the marble to the spindle, and the point of contact from the marble to the top of the tube is along the greater surface area. But it's considered
That's pretty cool. Somebody went,
as long as your weight is balanced, this thing will spin as long as it can. So what we're going to work on is how to make this tube and how to make this spindle, and then how to make a mechanism connected to the tube on which you can either add an arrow mechanism or you can make your ornament blacksmith themes or rooster themes. A lot of them are rooster themes because, and I'll say this because this book, Kelly has pointed out English grammar, starting on page 300, there's a section called weather themes. And that's the name they call them because the predominant theme was a rooster. Roosters are very important in anything. If you want to look at some bullets in there, it starts on page 300. Now what we're going to do, there's a couple. Let me get my next. This one right here. Okay, so this is the tube. I think it's going to be a these, I think it's, I use this, looks like this schedule 20, but you can use a thinner gauge tube if you want to. But what we're going to do is we're going to use a spring swedge or a butchering or a guillotine tool to bring in the edge or the tube circumference down to a point of about 1/8 of an inch. And we'll cut it off and we'll use a little jig to close that off. That's how Kelly made this one and this one. I made this one. And I'm going to tell you how not to make it. So this is the first painting. There's a seam that runs on the inside of this steel tube. And when I got down close to the end, I'll pass this around, the seam started splitting. Probably because the material, the work material, was a little too thinly right here. And then it never could get it to close.
Hey, Tony.
So then,
Don't
yes.
forget you have an audience on this side and a camera.
Oh, so Kelly said, just use a MIG welder to close it. So I set the MIG welder to way too high of a wire speed and voltage, and I burned a hole in it. So don't do this. Do it the way I'm going to show you. I also, when we make the component that goes across this, there's a couple mechanisms that we can set that somewhere. I'm going to go ahead and get started on it. So we use this is about 8 inches of, well, it's about an inch on the outside. Actually, no, this one is an inch close it off. We're going to pinch it. And then Kelly made this. It's just a piece of sucker rod that you round it over. We're going to clamp that in the vise and use that to close the pinch part all the way in. And that one looks gross because we're ignoring how it looks. Okay.
Would it help to knock that seam down before you
I didn't have a problem with it when I used my skillet pipe skillet. The one that Kelly and I used, say, a flat, had a really fine die, and I think maybe that fine die probably cleaned out through went there where it was a bad occurring. So I have a rounder die. And this one just sits in the hardy hole.
Well, wait, those that he can have tips and try to make those, if you want one, talk to one.
Okay, let me get this in heat. In fact, while this is heating, I'm going to talk about another one. So, actually, I'm going to do a little safety briefing too. Where's the pipe that you carried in? So, if anyone is going to want to do this for their competition, which I encourage you to, there's a section of steel pipe here. We'll cut it into 8-inch sections and we can take an 8-inch section. One of the things that we did the other day when we were talking about this was Kelly used a longer piece of pipe. So Kelly used a longer piece of pipe, and if there's air on the inside, it travels up the pipe. So even just holding the pipe, it was about 30 inches long, even holding it was a little bit hot. So he taught me a trick, and that's when you plug one end of the pipe with a rag or with clay, and then you polish and wetted it. What that did was that created like a semi-vacuum. It really slowed the heat coming up the pipe. If you're going to cut it into an 8-inch section and work that, that's fine. But if you're going to leave it long and work it, plug the end and soak it. And you're going to have to just be careful of where you point it to see if you can hit it. That was like it, yeah. So just be careful where you point it, because if you're going to go put it in the water to cool it for any reason, you've created a steam can. So you just got to be mindful of where you
Plug it with a wet rag, you can clean it. If it gets too hot.
if it gets too hot. And what you're hoping is, what we did was we did maybe a couple of heats as the heat traveled through that semi-vacuum that's in the tube. And when it just got a little bit too hot to hold, we quenched one in. You just got to be careful when you quench it that you don't make it. So another thing we'll talk about while that's heating up is the arrow style. I'm just for simplicity's sake, I'm going to call it an arrow. But it's the cross piece that sits on this tube that where you're going to put your wind catch mechanism, whether you're going to use a simple arrow or an ornamental style or whatever, or a banner. You can do a banner on this thing. But a banner would be too lateral and it would not have a balance rotation. So we're going to guess we're just going to make a simple arrow. And I'm not going to make Nick hold this one up. We'll flip this over. Basically, I'm going to just take some 3/8-inch round bars, touch welders. I'm going to use half face blows on the both side and the far side of the hammer. Narrow a section in the middle to about 1/8 inch thick. There we go. 1/8 inch thick by 1/2 inch. Then you can use a section of 3/8 inch by 4 inches, hammer it a 1/2 inch or 1/2 inch by 1/8. But I'm cheating and using 1/2 inch by 1/8 for purposes of counting. So what these are going to do, these are going to make one side of the arrow piece that's going to go across with a bend in it, and then this bracket is going to bend, and they'll eventually get riveted together to make this. This right here is where the tube goes, and this will be a friction stud. So these will get riveted in, and I would, for this tube, I would probably close this diameter, inner diameter a little bit more, so And so we'll probably go switch back and forth between the arrow and the so you're going to want to go about an inch back from the end. Right there. And then just start tapping and rotating your tube. So I'm rotating in the direction where this stopper is, and that's pretty much keeping it in place. Part of Nick's presentation. We're just starting to bring this is just one beat. It's a little out of round, but I can fix that over the course of several beats. We're just starting to fix this in. Huh?
What happens if you get too aggressive?
You make an oval. Yeah, you make an oval, you collapse the tube. Another way to do this, if you don't have a guillotine tool or a spring swedge, you can still make areas of your swedge block and hold this at like a 45-degree angle and hold the hammer at an even steeper angle and then just work the end of the tube in one tiny little tap at a time. The only thing here is that since you're not doing it on both sides, you're going to be a little more delicate with your hammer. What you're doing is you're bringing a section of tube in a little bit, and then the next one you're going to work the next section, and it's slowly going to bring the edge of the tube up towards the middle. And then when it's finally at the top, you can close it off. And if someone wants to, after we open this up, if someone wants that, they want to try to close it off with the swedge just to see if it works. Huh?
Are these at Gabby's?
There are some at Gaby's for sale, I believe, or some that belong to the club, but Chip?
Yeah, the buckets at Davies.
Are these at Gaby's for sale?
Davies for sale.
Okay, so yeah,
And they're 45 apiece.
and they come with one,
They come with that size.
they come with a set of dies. I made these dies for this.
There's dies made out of.
This is just mild steel.
Is there any type of warranty?
I'm not the one selling them, so I don't know.
Depends on how big you are.
Huh?
The warranty depends on how big you are.
Oh.
Got a 3:30. 3 minutes and 30 feet.
All right, so I'm just going to keep working this in.
So you're rotating it so it doesn't just stay in one spot and you can't unbend it.
Yeah. And you can be a little bit more aggressive. You don't want to be too aggressive in the guillotine tool, but you can be a little bit more aggressive than you can if you're just trying to close the tube, because now you have force coming in from both sides, and that kind of keeps the structure of the tube. One thing I ran into is I made several extra dies for this guillotine tool, the style that Chip was talking about. And these are mild steel, there's 1-inch, shanks. I bought a bunch of shanks for party tools. So I was able to make dies with them, but since it's mild steel, it does deform pretty easily. So I've already grinded it in once, so I'm probably going to have to come up with a hardenable steel.
How about weld it a little hard?
You can do that. I don't know if that's going to eventually cause some upset. It might, but it's pretty short already. So maybe. Let me go check. It's a consumable.
What do you mean about doing it square?
Also, take off your ring.
Is it cut off that same?
No, it's not cut off that same one. That's just some black pipe from Home Depot.
Right.
This is just pipe that we had made.
There could be some liability. Is that what you're saying?
While that's heating, I'm going to grab that 3/8 document that in there.
Use that in front of you, get the drill while taking your seat out.
So this one, I'm going to be thinning the middle section so that it can act as the other side of the bracket. So you just basically isolate.
This right here. Riveting spot.
Yeah, it's this spot. It's this shoulder right here and this shoulder right here. This thing's banging. Is it because of this? So as you can see, I've worked the shoulder here down to about 1/8 of an inch, and it's spread to almost 1/2 an inch wide. So that's going to simulate the same dimensions as the other side of this bracket.
You mark the distance already beforehand?
What?
The distance.
No, I didn't mark it because it can be as long as you need it to be. And in fact, if you wanted to use, if you don't have 3/8 and you have 1/8 inch by 1/2 inch flat bar, you can use that for the whole thing, and then you don't even have to do this stuff. This isn't just because I had some 3/8 on here, and I had one tiny chunk of 1/2 inch by 1/8 inch. I might switch angles. This is really yeah, I'm gonna switch. Yep. Let's see if I can close it on this. May not be able to, but I'll try. Also, notice all the scale that's coming up? There's another safety briefing coming up in a minute.
Yeah, you got like an oval shape. It's right there, yeah. Now it's starting to get rounded.
Yeah.
You're holding it pretty well on there. Feel good.
I think I want one more heat.
So we boots.
So now with the near side, even though I'm going to do half face blows over here to just mark it. And then you just got to draw this section out until it's all one uniform dimension of 1/2 inch by 1/8 inch.
Yeah.
Close.
Well, oval shape. You're almost there. And you're looking to close it with doing this, or just getting close to it?
You're getting
And then
close.
weld it.
You're getting to about 1/8 of an inch. Because what's going to happen is this throat right here, you're going to cut it like right in the middle, and that'll leave enough material to close it. And the safety briefing, you'll see the scale fall out of the bottom. When you're working with this and you hold it up like this, top scale will fall and hit your hand. And it'll scare you the first time it happens, like it did with me. I was like, so I think this is probably ready to cut. Yes. Yes. Steam cannon. Yeah. So that's what the whole. And we're at we're at this stage right here where the whole diameter is about 1/8 of an inch. So I think we're ready to cut it. I just use a hacksaw. Huh? That'll no, I'm gonna close it a different way. I want it to be a clean cut. So
Getting it all straightened down. You're getting it all straightened down.
Well,
can I get a holder?
might as well show the step he's on.
Yeah, go ahead. So that's pretty much it with this. You can manufacture it yourself if you have angle iron and a welder, but they're for sale. It gets hot. So the next step for closing that tube off, you can make one of these, or the first person who promises that they're going to make a weather vane for next month's competition can take this with them.
That's 3/4 inch.
That's empty.
It's 3/4 inch sucker rod, rounded over. So if you can get a section of sucker rod, you can make this yourself. You just want to make sure that you have enough length, because this is just going to get clamped in the vise. But you want enough length to be greater than the section of the tube that you're going to be closing off, because you don't want to make this short.
Now, is this the size that you have for sale right now?
No.
It's all gone.
It's all gone?
Did you say reserve a few for me?
They all just got around there and bought it all, but I can't.
Okay.
That's what happens when you supply and
No,
demand.
I said I'll take a few.
Yeah, Kelly's got more than that room right there.
Looks like you've only got one.
Okay.
Really? Okay.
Bring it along too. It does need a little bit more material from down here. All right, let me go ahead and get that clamped into the vise. The best way to do this. Okay, so this is clamped pretty aggressively in there, and I'm going to be standing in the frame. So if you want to see it, you'll have to come over here. So with this,
5 or 6?
hold it over the
corners, all the corners. Me and Kelly, we did a little class, but he used his method. Like we were at Frisco South, and he would use the ball screen hot tool and dimple it in on the railroad spike to start the pin. Flip it on the other side, do the same thing.
I think with the heat being the way it is, I'm only going to work on one thing at a time. When I was trying to work on both, okay, that tube is almost closed. Once the tube is closed,
Get some that are like
foam stations on it, you're essentially there. At least with that spindle tube. So that soy tube will fit over a piece of cardboard and sucker rod. And in fact, that's the So the tube is one part of the tube spindle assembly. And there's marbles that are falling away. The bottom is the cover right there. You have to take a little divot in there where the marbles is between them. All that going in.
I think we got some at Frisco. A little quart-sized paint can of this. Or I just like make money and then get the satisfaction of being like, maybe they post a picture of it or something.
Right.
The little things.
So after sound and tube, I'll just take a real quick dip, and that's the sucker right there. Sucker right there. And then that's pretty much it. And all three of them.
That's just like a habit that happens. Danny, you did the same thing. The marble thing.
Tube spindle, where you have
I had no idea that.
we don't have to necessarily make a package.
Technically, it was in the think about it. That's it.
This is one idea. This is just basically what I did with the bending jig that I have. Just basically 1.5 rotation.
James is like, what do you think? I got the recording going right here.
Chop this tube.
I got the scar.
And this will loose it. And I'll get it all this shit. Close it off a little bit. Or, put your tube on the left horn, just tap it here with the heat, and that will basically flare the bottom and then whatever you have on it. Since you want things to catch the wind versus with the tube, you will with some sort of temporarily fixing whatever method of arrow that you're using to fix the tube. You probably don't want to make it permanent because you could weld it. But if you make it permanent, if you put a weather vane up and then your farm is still around in 100 years and then take it down to do maintenance on it, there's not much they can do with something small. So that's another style you could follow if you want. close off this one. Because of the differences in the roundness of design. What I'm going to do is I'm going to split the bottom and rise each half out, and that's going to be the bracket that sits on the eave of mine. But if you wanted to mount it to a sidewall, you can use the bracket style that Kelly has, which is a flat bracket. Let me get this thing out enough, and then I'll go get this bending jig, and I'll show you how it bends. It's going to get and twisted when I put it in the bending jig, but I want to try to keep it as straight as possible.
Don't sell it. And then my father's like, you know what? I just went my Blacksmith and tool and my will.
So I also have been seeing these online for a while, and I decided to go ahead and make one. Just a really simple bending jig. Take a section of that tube, because I was specifically wrapping around that half. So I took a section of tube and just welded it to a piece of plate steel with a 1-inch shank, and then I welded this stopper here. So when you hear this in the party hole, we're gonna put an angle. Actually, we're not going to put that much of an angle, but we're going to put one end of the arrow at one side of the bend in here and put a bend in it and then wrap it partially around here, and that forms that top bend. This I need two. So the bend direction is always the direction opposite of the shoulders. So if the bend is going to go around this radius, the shoulder needs to be facing towards me. So I'm going to put a little bend in that. And then, actually, and then kind of, I don't know that I have enough heat, but my next heat, I'm just going to bend this back up there, and that will form one half of that. I'm going to go heat this up, and the next time I put it in, I'm going to put the unbent side in here, and then just use tongs to bend it out.
So I won't have before it starts throwing stuff.
So what we're not going to do is to attach the bracket to the arrow shaft. You can do it any way you want to, but for purposes of long-term maintenance, I'm going to rivet it. So when I do my numbers, you can rivet. You can use screws and bolts and all that. Technically, you can weld it if you want to, then it's permanent. Now, there's a way you can also do that. If you have a loose fitting bracket on your tube, you can cut a hole in it and tap it. You have like a die and tap kit, and then just use a set screw to hold it in place against the tube. Any way you want to do it, any way you want to fix it to the tube is fine. As long as it's at some point in the future, you can trim and erase all of it. Alright, so now I'm going to put the other end here. Then when I just bend it out, I've got roughly 2 halves of the bracket. Now sizing it is going to be depending on what size your tube is. You're not constrained to use 1-inch tube. You can use half-inch copper. You can use whatever you want for the however you decide to close it. But once you get this bent, the other bracket will be the other end of it, and then when you put holes in it, you can bolt it together or rivet it together, just like the example. And what you would want to do, I didn't do this all that well, you'd want to make sure that this was roughly in the center. If you don't put it in the center, that's still not insurmountable, because what matters the most is the distribution of weight. So if you have more weight on this side of your fulcrum, that will balance out the fact that you have more weight on this side. So there's that.
I just found
Okay, so that's pretty much it. So now both halves of the bracket. And you can take as many heats as you want to adjust the opening in here to match whatever tube size you're working. And it's okay if it's out long, because all you're really needing to do is make sure that once it's in place, it's affixed to the tube. So even if it just pinches a friction fit here and here, that's perfectly fine. You don't have to have that be a perfect surface. That's pretty much it. The arrow. So, I think of anything else. Oh, ornamentation. So basically, excuse me, James. Excuse me. Oh, there is one other method that Kelly wanted to talk about. The brace is that you take a piece of whatever your steel on it is. If you're not getting to use the tube with the marble rotation, if you just want like a cuff that it sits on, you can mount it on a cuff like this. This is a free spinning cuff because the shaft that it's on is tapered. So this isn't forge welded, which is really awesome. And the spindle rotates freely inside of you. If you're going to not use a tapered shaft, you'll need a forge weld around onto this. This, I didn't get a weld on this one because I was running out of fuel. Didn't get hot enough, so I tried to weld it, but it's still really just a little bit. But what you would do is, because you're trying to reduce friction, if you're going to create an arrow or a banner or whatever that's going to sit on top of this, the point is that it comes in contact with this cup. It needs to be as frictionless as possible. So if you're going to use this method, you're going to get a really good smooth poly on the bottom part of this ring. And if you're going to set something down on top of it, you're going to want a pretty good polish on the bottom side so that you have the least amount of material heating. And I think that's it, except for ornamentation. So one of the things I was going to do steel, but lighter material like copper, aluminum, brass is also good. What you were looking for, this is arrow components that I made. I cut these out, hammered them so that there's a fletching of an arrow and the tip of an arrow. And those would go, where's the example? So these would go on either side of this one. However I want to fix it, I could either cut a channel in here and then run rivets through it, or I can brace it, or really you can just bolt it on. But the side that has the highest amount of drag coefficient is always going to be the side that touches the wind, but this is always going to point you to the wind. I have some extra copper. If someone promises to make a weather vane, you can pick from the copper. What else? Oh, there is one last method. So, here on the arrow, so there's another way. If you don't want to make a bracket, you don't want to upset material and then hammer it and punch a hole. This is just a piece of 3/4 inch by 1/8 inch flat bar. All I did was I used a cold chisel to mark it in 3 different enclosed lengths, and then I punched it, used a hot chisel to cut all the way through. And what I'm going to do is I'll throw this in the forge and heat it. These 2 outsides will be oriented one way, and the inside shaft will be oriented the other way. That will form an opening. So we'll do that. The last thing I demo. Ornamentation is completely up to you. You can look at some of those pictures, and you can just Google historical weather vanes, there's a ton of really cool ideas. If you want to make it themed, like something that's important to you, like Blacksmith themed or farm themed or sports themed, or whatever it is you want to, the sky's the limit for whatever you make. And hopefully, what will happen is you'll make a weather vane, and then you'll mount it on your shop or your house or your chicken house or your chicken coop, and you'll take a picture and send it to me, and I'll put it in the newsletter. My wife has already forced me to make her a rooster-shaped one. I haven't decided yet. That's quite a hard because I don't really work so much. I do have huh? I was thinking about it, but I have 1 month, and it took me 3.5 weeks just to make this jig and put together the demos. We'll see. This last one is just another alternative to the arrow styles that you can fix on the tube. And in fact, it's all I'm going to do is use this to open up those 3 shorter sections, and then I'm just going to drift it with this open. I'm going to drift it in here. So, the trick is to make these 2 go one way, and the middle one go the other. Is that enough? Yeah. A little bit more. Make it one more. I think it's just dripping over this.
Yeah.
I mean, that's enough to demonstrate technique. I would have a tube that I was working with, it doesn't have whatever diameter tube I'm working with, I would drift it to just maybe like a 64th of an inch smaller than the tube, and then you can tap it down onto the tube and it's got a good friction. There you go. No bracket needed. All of the pieces are hot, so be careful, but feel free to examine them. Any questions? Any ideas? Anyone going to make something?
Very good job, Tom.
Thank you. Have you already decided what you're going to make?
I'll probably do it.
Well, there's 2. You're going to make one. There's an angle iron around somewhere. Cut off an 8-inch section in 2. Feel free to take it. If you're going to make an arrow style, feel free to grab a couple of pieces of copper. You don't have to make. Also, you don't have to make it as big as we made it. You can make a tiny little desktop version.
Kelly
For the
Crane size?
Huh?
Kelly Crane size?
Kelly Crane size. Just for purposes of the competition.
Yeah. That's a good idea.
All All righty. So yeah, that's called a bolt handle. The industrial construction industry uses it to align converters when they're going to drive resistors. So they'll get the converters close and they'll drive that bolt to the end, and then they'll knock it through.